Hello viewers, in the last lesson we were able to discuss the theorems of probability. So if you're new to this channel, kindly make sure you subscribe, like and share the video. In today's lesson, we'll be dealing with some of the examples under the aspect of probability. We were able to prove the 5 theorems in the aspect of probability, but there's still one theorem left, or it's not actually, we can't classify it as theorem, but we can also call it the theorem, which is actually the general formula of probability, and which we will be applying that formula in the examples we're going to be treating in this lesson. Without further ado, let's move into what we have in this lesson. So, the general formula in which we'll use to solve problems in probability says if S represents the sample space then A is an event in the sample space S, then the probability of event A is definitely given by the number of event A divided by the number of the sample space. So some are classified this as a theorem, so you can take this as theorem 6. We treated this up to theorem 5 in the last lesson. So let's be fast and let's move to some of the examples which we can use this formula to solve. So the first example we're going to be treating in this lesson is the example that says in a single throw of 3 fair coins, find the probability that 2 eggs and 1 tail appear. 2 eggs and 1 tail appears. The second says find the probability that at least 1 head appears. The probability that at least 1 head appears. So in this kind of problem, we're going to be drawing a sample space. We're going to be drafting out the sample space as the case may be. If it is in the situation of the dice, you can draft out the sample space for a dice. If it is in a situation of a coin, you're going to be drafting out the sample space for the coin. And the question says a single throw of 3 fair coins. So we're going to be drafting out the sample space for 3 fair coins. And there's a trick in which you can use to draft out the sample space of coins. And that trick is definitely the tree diagram. So you can use the tree diagram to generate the sample space for coin, either 2 fair coin or 3 fair coin or 4 fair coin. So let's quickly use the tree diagram to generate. I know a coin definitely be involving head and tail. The coin will be involving a head and a tail. So you can have head, and here we have tail. We have head view. Then you can move further and say this head will generate another head view. So we have head, tail. This will also generate another head, tail. If you are dealing with 2 fair coins, then you can stop at this point. but we are dealing with 3 fair coin. So we'll also move further and say this gives us head, tail, and this will also give us head, tail. This will also give us head, tail, and this will give us head, tail. So we can now draft out our sample space from these 3 diagrams. So we finally have head, head, tail, head, 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 head. We have head, head, head first. We also be having head, head, tail, comma, head, head, tail, head, head, tail, comma, head, tail, head, head, tail, head, comma, head, tail, tail, head, tail, tail, comma. Here we have tail, head, head, tail, head, head, comma, tail, head, tail, tail, head, tail, comma. We have tail, tail, head, tail, tail, head. We have tail, 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 tail. So we count everything we should so add up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And how do you know it will add up to 8? Because we are having how many coins? We are having 3 coins. So we just say 2 raised power n, where n is 3, the number of coins, and 2 raised power 3 is 8. So the number of elements in the sample space must not be less than or greater than 8. So since we have been able to generate our sample space, so we can now solve the problem. So the first says we should find the probability that we are having 2 heads and 1 tail. 2 heads and 1 tail appear. 2 heads and 1 tail appear. Probability that 2 heads and 1 tail appear. The probability that we have 2 heads and 1 tail and 1 tail. The probability that we have 2 heads and 1 tail. So now let's take our sample space. What are the elements having 2 heads and 1 tail? So here we have 2 heads, 2 heads, 1 tail, 2 heads, 1 tail. So here we also have 2 heads, 1 tail as well here. That's 2. Which other one? 2 heads, 1 tail. We also have 2 heads, 1 tail here. That's 3. 2 heads, 1 tail, 2 heads, 1 tail, 2 heads, 1 tail. And that's all. We have 3. 3. That's number of 2 heads, 1 tail over the total number of sample space, which is what? Which is 8. That's 3 over 8. That's 3 over 8. So your answer is 3 over 8. So we can give it in decimal points. Yeah. Alright, that's the decimal points. So the second question says at least, please take note of that word. You can also be asked that at most, but it says at least 1 head at least 1 head appears. At least 1 head appears. That is, you definitely check the ones having at least 1 head. That is, the head may be more than 1, but it said at least. That is, there must be at least 1 head. So let's say this is having 3 heads. So it definitely counts because we are having at least 1 head here. So here this one also has head. So we definitely count everything that has head. So 1, 2, 3, 4, 5, 6. This also having head. 6, 7. It is only this one we will be counting because this is not having head. So that's definitely. So the probability of at least 1 head is definitely 7 over 8. So what if we are asked to find the probability of at most 1 head? The probability of at most 1 head, at most 1 head. So then that all this one is trying to tell is that the head must not be more than 1. So let's say the one that their heads are not more than 1. This one is 3, it's already more than 1. This one is 2, it's more than 1. This is also 2, is more than 1. This is not more than 1, this is 1. So 1, this counts. This is more than 1, so we can't count it. This counts 1. This is not more than 1, that's 2. And that's and 3. This is also not more than 1. So at most 1, at most 1 8. So that's 3, 1, 2, 3. So that's the 3 over 8. And that's the final answer to that. So let's quickly move to the next example. Let's quickly move to the next example. So the next example says, in a single row of 6 fair coins, in a single row of 6 fair coins, find the probability that at least 1 egg is showing up. Fair coin 6. The number of coins is n. N, let's say n, the number of coins, or let me just say number of coins is equals to 6. Now look at this. The number of coins is 6. So if you want to solve it using sample space, you have to generate a sample space for 6 fair coins. So you'll be having egg up to 6 times. So it will be too bogus. So it is advised not to use the idea of sample space for this kind of question. For any number, any question in which the number of coins is more than 4 or more than 3, it is advised not to use the idea of trivial diagram, because it will be too bogus and too strenuous. So this question says we should find the probability that at least, find probability that at least 1 egg is showing up. 1 egg is showing up. Probability that at least 1 egg is showing up. So in this case, if you have to find the probability that at least 1 egg is showing up, so that will definitely be the complement of the probability that no egg is showing at all. So to make it easier for you, you can find the probability that no egg is showing, then you subtract it from 1 to get the probability that at least 1 egg is showing. And you can look in your sample space, you only have one element in which no egg is showing. For example, this one, the only element in which no egg is showing is tail. If it is up to 6 coins as well, the only one in which no egg will be showing will be tail. That is 6 times tail in 6 places, t in 6 places. So you can apply that same knowledge to this aspect. So you can say, let the probability that at least 1 egg is showing to be equals to probability of A, and the probability that no egg is showing equals to probability of B. That is, the event of 1 egg is showing is A, then the probability will be P of A. So the event that no egg is showing represented as B. So definitely the probability that at least 1 egg is showing will definitely be 1 minus probability that no egg is showing. So the probability that no egg is showing, the probability that no edge is showing will definitely be 1. That is, the only situation whereby no edge is showing will only be once. And that will be, that's NB over NS. And I already told us NS for coin is definitely 2 raised to power n, where n in this situation, not this one is the number of coin, and here the number of coin is 6, 2 raised to power 6, 2 raised to power 6. So definitely the number of elements you will be adding in your sample space is 2 raised to power 6. So in that situation, your probability that no edge is showing definitely be 1 over 2 raised to power 6. 1 over 2 raised to power 6. So definitely the probability that at least one edge is showing, so the probability that at least one edge is showing will definitely be what? 1 minus 1 over 2 raised to power 6. 1 minus 1 over 2 raised to power 6. And if you do that very well, this will give you 1 minus 1 over 64 because 2 raised to power 6 is 64. And that should give you, in fractional form, that will give you 63 over 64. That will give you 63 over 64. You can also put it in decimal places. And that's the answer to that. So we move to another example, example 3. So the third example says a class of 8 men and 7 ladies. A class of 8 men equals 8 and 7 ladies equals 7. 2 students were selected randomly. Number of selected students. 2 students are selected randomly. 2 students are selected randomly. Selected students. Equals 2. Then it says they are selected randomly to represent a class in a debate. Find the probability that the students are that the students are both ladies. The probability that they are both men. The probability that they are of same sex. You also have to find the probability that they are of the same sex. First solution to that. So the first says to find the probability that they are both ladies. But the total number of sample space, NS, the total number of sample space, that is the possibilities of selection. In this situation we are dealing with selection, and if you remember very well, when we are dealing with selection, we should be talking about combination. We have permutation and combination. We use combination for selection. We use combination for selection. So in this situation, what's the total number of students in concern? The number of students in concern is 15. And the total number of selected students is 2. So the number of sample space will definitely be what? 15 combination 2, that's n combination r, where n is total number of students and r is the selected student. So that's n combination r. We're dealing with selection. So that would be 15 combination 2. So your ns is 15 combination 2. So the probability that both students, that is these two students, both are ladies. Probability that both are ladies. So you can let the probability that both are ladies, let it A. You can say P of A. The probability that both are ladies, you can call it A, and probability of both are men, you can call it B, while the probability of same sex, you can call it C. So the probability of both are ladies, let's call it A. So that was definitely the combination. You also be using the idea of combination. That is to get the number of selected ladies divided by the total number of sample space. So that was definitely, men is also involved. And in this situation, how many men are selected in this particular situation? That is both ladies. So 0 men are selected. So that will be definitely, and what's the total number of men? Total number of men is 8. So that will be 8 combination 0. 8 combination 0 because we don't want men in A. We don't want men at all. So that's why it is, and the number of men here is 8. That's why it is 8 combination 0. 8 combination 0 multiplied by total number of ladies is 7. So that will be 7 combination. What's the number of selected ladies? 2, because we want the two students to be ladies. So that will be 7 combination 2. And what's the total number of sample space? That's 15 combination 2. 15 combination 2. So if you do this well, you should be having 0.2. You should give us 0.2. As you follow in class, if you have a calculator with you, you can confirm that in your calculator. So the second question says both are men. We are going to do it the same way we've done this, the same idea we used to do this. So the probability that both are men, we said you should represent it as P probability of B. So that will be equal to, and in this situation, how many men do we need? We need both to be men. That is, the number of selected men will be what? Will be 2. That's definitely 8 combination 2. Unlike this one, times, but we don't want ladies at all. So that will be 7 combination 0, because number of ladies is 7 and the number of selected ladies is 0. We don't want ladies at all. Over the total number of sample space, which is what? Which is 15 combination 2. 15 combination. So if you do this very well, with the adding, you should be having 0.27. You can check that calculator. So C says same sex. So if you say same sex, it can be occurring in this situation. They don't tell us whether they are both ladies or they are both men, but they must be both same sex. So two scenarios can happen. It's either they are both ladies or they are both men. So that will definitely be, let's represent that one as probability of C. That will definitely be probability of A or the probability of B, or the probability that is either both ladies or both men. So I know we are dealing with the probability. That definitely means addition. That will be probability of A plus the probability of B. Probability of B. So the probability of A, which is 0.2, plus the probability of B, which is 0.27, and that definitely was 0.47.
0.47.
0.47, and that's the answer to that example. So in the next class, we'll be discussing about the other aspects of probability, in particular conditional probability. So if you're new to this channel, kindly make sure you subscribe, you like, and you share the videos for those that will find it helpful. Thank you.